Okay, as promised, page 762, number 6, you're going to need your book and you're going to need your calculator. So the very disappointing news is that there is not one problem about Phoebe in this whole section. So I decided to do the spaceship problem, and we're just going to pretend Phoebe's part of the spaceship. That's the best we can do at this point. Number 6, page 762. When a spaceship is fired into orbit from a site such as Cape Canaveral, which is not on the equator, this graph does not go through the origin. It goes into an orbit that takes it alternately north and south of the equator. Its distance from the equator is approximately a sinusoidal function of time. Suppose that a spaceship is fired into orbit from Cape Canaveral and Phoebe is inside. 10 minutes after it leaves the Cape, it reaches its furthest distance north of the equator, which is 400 kilometers. Half a cycle later, it reaches its farthest distance south of the equator, which is on the other side of the Earth, of course, also 4,000 kilometers. The spaceship completes an orbit once every 90 minutes. Once every 90 minutes. That must be the period. That must be the period. And if it's alternating between 4,000 kilometers north of the equator and 4,000 kilometers south of the equator, therefore the amplitude must be 4,000. Okay. Alrighty, so here's my equator. So we're going to say 4,000 kilometers above. This looks good. And 4,000 kilometers below. And this is not the equator, Miss Babiak. And this is time. And this is height in kilometers. Label your axes. I was pretty strict about that previous word problems, and I'm going to be just as strict in these word problems. Okay. Where are we starting? 10 minutes. This is time in minutes. Okay, and then 90 minutes later. So last I checked, 10 plus 90 was 100. 10 plus 90 is 100. Okay, this has no vertical shift, which is great. This has no vertical shift. So I start at 10 seconds. I'm at 4,000. Is that what it says? 10, not 10 seconds. How about 10 minutes, which is still super fast. And then here. Okay, so the period is 90. Half of 90 is 45. So halfway between 10 and 100, we're going to be, let's say, here. So this is going to be 55. And I'm going to draw. I'll move my hand in a minute. So here we go. From 10 to 100 is 90. My amplitude is 4,000. So 2 pi over b is equal to 90. I believe that gives you b is pi over 45. B is pi over 45. And if I'm wrong, I won't know it. You're probably screaming at me, Miss Babiak, it's not 45. But I think it is. I'm pretty confident in my 45. Okay, so the amplitude is 4,000. Again, this is no sinusoidal change, so I don't need to say 20 plus 4,000 or 16 plus 4,000. It's just flat out 4,000, which is great. And then this is the cosine of b, which is pi over 45, theta minus 10. All right, that was part A. That's already part B. So it says use your equation to predict the distance of the spaceship from the equator when t is 25, 41, and 163. So this is 100% just a matter of calculator utilization. So I'm just going to choose one of them, and you can choose the other. So how about I choose t is 41? And I'm going to stick to radians. So in case you weren't here for the last video, plus it doesn't hurt to reinforce how to do this. Mode, I'm going to arrow down. I'm going to be in radians. I'm going to quit out, and now I'm ready to do the problem. So this is 4,000 pi over 45. 41 minus 10 is 31. So how about the cosine? I forgot a little piece of information there. Yeah, who cares? Leave out the function. No one will notice. 4,000 cosine pi divided by 4. Again, the pi key is above the caret, and that's right below clear. So pi over 45 times 31. Yep, negative 2,237 about. How is that possible? How on earth is it negative? Well, let's look at our graph. If I'm looking at 41, time is 41, okay? It's there-ish. You are south of the equator, and so that's why it's negative. The negative indicates that you are south of the equator. So I would write this as 2,237 kilometers south of the equator. I would not write it as negative. I mean, like, what's negative 2,237? So we're using negatives to help us graph, but in the big picture, I would not say that the distance is negative 2,237. Oh, and by the way, traveling in reverse, that's not negative distance. Traveling in reverse is not negative distance. You're still traveling a positive value. You just happen to be going backwards in reverse. So that's a major misconception. Okay, part D. Calculate the distance of Cape Canaveral from the equator by calculating when t equals 0. Oh, this is another plug and check. You can do this. When t is 0, so my theta, I'm sorry, my calculator was in the way. So 4,000 times the cosine of pi over 45. And then 0 minus 10 is negative 10. So times negative 10. 3,064. Okay, so that's where Cape Canaveral is from the equator.